This is a video which will probably bore the pants off most people, but I'm really quite excited about it, so I'm going to put it out there anyway. Unfortunately, the amount of people who can probably understand what this is on about is relatively limited, so I'm kind of constricting my viewers market, as it were, but nonetheless I'm going to give it a go. My point is for all those who say that the Bible can't be true because if you look at the time it takes for a star's light on the opposite end of the universe to get to us, it should in theory take several billion years, and therefore you can't actually take a literal view of Genesis because it would suggest that the age of the universe is more in thousands of years rather than millions or billions. Unfortunately, if you don't understand how they gauge the age of the universe using the time it takes for the light from stars to travel to Earth, then unfortunately this video is going to be completely pointless for you to watch. So, if I was you, I'd watch something slightly more interesting and valid like Mitchell and Webb. They're brilliant, to check them out. Now, for those of you who do understand the way that the age of the universe is calculated using this light, then my point goes to you, because I have a possible explanation as to how it could still work. Because, obviously, the amount of distance light travels in a year is called a light year, and because they calculate using certain ways, certain methods, which frankly I think are slightly inaccurate anyway, but that's another point. Since they calculate the distance between us as billions of light years, since light is actually getting to us, obviously that means that the universe has been in existence for at least that many number of billions of years. However, the space that light is travelling through in order to get to Earth is deep space. So there's very little mass or anything like that. It's outside of galaxies, it's outside of our galaxy cluster. Most of it is just going through space, where there's no real mass around it, and as such the gravitational level is very low. Now, according to Einstein's theory of relativity, which has been proven, gravity does in fact distort time. Therefore, when you're in an area of high gravity, time slows down, and when you're in an area of low gravity, time relatively speeds up. Now, we live on Earth. Earth is part of the solar system, which has the Sun. The Sun is part of the galaxy, which is the Milky Way, and the galaxy is part of our cluster of galaxies. So we're in an area which is comparatively very, very high level of gravity. We're on Earth. Wherever you are in an area of very high gravity. And in comparison, deep space, where there is no mass, and therefore there is almost no effect of gravity, this has virtually no gravity whatsoever in comparison to where we are. And as a result, time here, according to Einstein's theory, which has been proved by objective tests, time here will go a lot slower than time in deep space. Therefore, if we use the physics equation speed equals distance over time, where time is a variable and time is actually going slower here relative to in deep space, we can therefore work out in the same amount of time, which is changing depending on where you are, a larger amount of distance is actually going to be covered. So despite the fact that only a certain amount of time has transpired on Earth, the amount of distance covered in deep space by that light could actually be vastly greater. There are equations for it, but in order to work that out, you need to be able to work out the mass of the galaxies and the galaxy clusters, which obviously is going to be an estimate at best. But nonetheless, using that equation, which like I said has been verified by tests using the Earth's own gravitation pull on different clocks, we can work out that the amount of distance covered relative to what you would expect in deep space would actually be massively higher, therefore gauging the universe's age as a lot lower than it actually is.